Well, good morning, good afternoon, good evening to all. Welcome you to today's RWG meeting. One quick announcement. So I want to remind folks, anyone interested in presenting, we do monthly meetings with the requirements working group. If you have interest in presenting, if you'd let me know, kevin.orr@incose.org. You can email me your interest in presenting. We have quite a few openings, so looking for some more volunteers to present. I also want to let folks know that we will have a session during the INCOSE IS. It'll be Wednesday, July 30th for about an hour and a half. So anybody that's attending the IS in person, we welcome to have you attend that, and it will be available for virtual participation also. And we'll be giving main thing introduction to the RWG for any new folks that may be around, as well as the project status on the various projects that the requirements working group is working on. But today, going to get a really good presentation. Topic itself is using AI for requirement development and validation of safety requirements. Our presenter, Akshay, is one of the co-founders of Saphira. His team has built the certified safety cases for robotic companies like Roco and 1X, including one of the very first for the humanoid robot in the home. Before starting at Saphira, Akshay began his career automating reliability engineering and testing for the Model 3 at Tesla, then built a career in machine learning working at PyTorch at Meta and the Vision Pro at Apple, and led a compliance automation team in the financial services industry at Citadel Securities. He sees robotic safety as the most important problems to solve in this generation to unblock adoption of millions of autonomous systems in every domain of life. So turn it over to you.
Perfect. Thank you so much, Kevin. To kick things off, as Kevin said, I'm Akshay. I'm one of the founders of Saphira. You'll see a little bit more about that in just a minute. We're a startup based in San Francisco that does product safety compliance automation. So you'll hear a little bit more about that in just a minute. And the way I've structured this presentation, which I think worked reasonably well this morning, but I think I have a little bit more material than time, so we'll try to balance things properly, is I will go over an agenda in just a minute with two key pieces of the presentation. I'll give a really quick overview about us as a company and the problem statement that we exist to tackle. And I'll mostly spend the presentation talking about what we have learned about building requirements, development, and validation life cycles using agents that might be useful to you guys. So it might be useful in terms of how you use LLM tools you're already using, things like ChatGPT, Gemini, etc. And it might be useful for building new tools if you guys are tackling that. And absolute worst case, it's a reason to come and check out some of what we're doing at Saphira and potentially use some of what we're building. Cool. All right, let me dive in. So as mentioned, we are a company that focuses on product safety compliance. We come from backgrounds in hardware design, bit of compliance software, and functional safety. My co-founder, Oscar, who's sitting right next to me now, and I split our careers across places like you heard earlier, Tesla, Apple, and Oscar's case, Amazon, and Twitter, now X. And we have a team of folks that came from the certification bodies, like Mahindra, came from Intertech. So we've seen a few different sides of the certification lifecycle. There's a little bit more context that I have in my notes in the previous slide that I should probably provide before we dive in, which I said this morning, and I just want to emphasize it again, that I'm really, really grateful for the opportunity to talk to all of you guys, because we started very deeply in the requirements development lifecycle. And you can see from our team that we did not come from the systems engineering world. So one of the first things we did as a company was we all joined INCOSE, and we learned so much from requirements working group. So all of Lou's writings, all of the discussion on the INET, meetings at IW24, which you had the chance to attend, all incredibly impactful for our understanding of the space. And as you can see, we've shifted a little bit in terms of depth of our focus, specifically on this problem of robot safety we'll talk about in a minute. But just want to express my gratitude to all of you from whom we learned over the last couple of years. Your feedback and everything has been invaluable. So I'm excited to share some more back to you guys, hopefully contributing from our growing area of expertise. So we were on this slide before, brief overview, agenda of the conversation. So as mentioned, I'll give a brief introduction to the company. And then after that, as we dive into the actual structure of the conversation, I'll talk about the motivation for the problem statement that we have around using agents for requirement development. I'll talk about the specific things that I really want to hammer home around constructing the correct context for the agentic actions you want to be taken by an LLM system. So that's a lot of what we'll focus on in the conversation. I'll speak about interacting with key analyses. So you guys may have heard the terms, and Kevin mentioned a little bit of this earlier. Tool use that is now being encouraged with many of the LLM systems that you guys, I'm sure, interact with as well. And we'll talk about how we can specifically fit that into the set of tools that systems engineers, compliance engineers, requirements engineers use today, especially from what we have learned working in product safety. We'll talk a little bit about the feedback and construction loop. So how we can create infinite loops that a system can iterate through to converge on a correct statement of something, to keep on providing feedback in a structured way until it has fully been addressed. And then we'll lead off with some challenges and open questions, closing thoughts, all that. So I'm going to try to wrap up the core of the presentation in about 30 more minutes. And then, as Kevin mentioned, we went up to an hour and a half this morning. So we'll use the rest of the time to answer questions and then jump around with additional material that we have in this deck, which will all be accessible to you guys afterwards. Okay, so some fun and funny starting place of just what we do as a company. So what is safety and compliance? This is something you guys probably know. Many of you are tangential or working directly in this space. So you're very familiar with the idea that our job is to make clear to the partners that we have how to interpret rules and regulations acceptable by industry to make sure that products are safe to use. Typically falls into three main categories that are our main area of work. The main domain, the most interesting space, most closely related to a lot of the requirements development lifecycle, is functional safety. These questions of, can a product harm the user in its nominal operation? And are there ways that that operation can be changed, altered, even at runtime to prevent those hazards? So as mentioned at the beginning, we've worked on projects like humanoids, where we've helped design the systems to prevent them from falling on children. So the detection mechanisms, the requirement flow downs that you need into your implementation to make sure that you actually have that kind of protection in place in your software, in the sensors that you use, in your diagnostic mechanisms for the sensors, et cetera, et cetera. And we've also done the same for many industrial products, such as autonomous forklifts that might crush workers if, for example, some hazard is not detected properly. We spent a bunch of time thinking about electrical safety. So can a product cause a shock or an electrocution of a user or cause fires? And we think about EMC, FCC, all these typical things where we consider whether a product can cause interference with other systems in our normal lives. So every one of these things boils down in some way, shape, or form to a requirements development and validation problem, which is why we think it's so exciting to share with you guys. So a little bit more of a statement of our company. Why AI? Why are we even thinking about applications of AI into this particular domain? Well, there are a bunch of things that we know, right? We've learned in the last few years that agents are really, really powerful. We know that they can take substantial actions within computer systems. That's a lot of what we'll present in this conversation, a lot of what we experiment with to drive our product forward. We know that they can do really impressive, powerful things in hierarchical ways, such as driving cars. Actually, I was going to note, we're here in San Francisco, so Waymo is everywhere. And I'm on a really funky corner in the financial district where the stoplight's a little bit weird, so Waymos often get stuck here. So the main background noise I'm going to ask you guys to call me on is that there's a ton of honking that happens right at the street corner because Waymos get stalled and people get stuck behind them, slamming on their horns, trying to get them to move, and that causes a lot of problems. But it becomes a requirement slowdown problem as well. Exactly the kind of thing that we're thinking about here. So with all this contribution to research, code writing, everything else, we want to make sure that the best of these tools are being applied to the edge of what we need as engineers, which is making sure that we're building the right thing in a compliant way that's safe to use for the public. And that kind of prompts the problem that we're solving as a company, which is that compliance is often still done in a very rogue way because there's high risk, right? There's this fear that if you get something wrong in a certification, in preparing a certification, then you end up with two big issues. One is that you can actually build dangerous systems, and that's a huge problem. And the second is that you actually create bottlenecks yourself for the certification process you're going to go through as a product developer. And so a lot of what we focus on, what we're going to try to present today, is how we try to protect against those failure modes of this kind of product and the kind of service that we want to offer. Okay. So what do? The vision of the company is to speed up compliance. We do that by helping people understand standards, by putting together validation plans, everything that boils down to the core of this presentation: requirements, construction, development, and validation. And we do this across a few different domains for a few different types of products, mostly robots again, but some scientific equipment, some work in automotive, some stuff in consumer products, functional safety, electrical safety, MC. And the piece we didn't mention earlier is we use a bit of cybersecurity. Cool. So I think I walked through this morning and I realized that this particular part of my presentation may not be as interesting. So I'm going to skip through this a little bit. I'll see if there's anything I really want to call out. I think the only thing I'll emphasize here is just the one statement that hardware compliance is a slow process right now because safety standards are really ambiguous. There's a ton of education that goes into the process, and there's a lot of manual work that gets done. We had some examples here, but I'll kind of run through this, and we'll come back to this as drivers for a lot of what we'll present later in the conversation. A lot of this manual work is really closely related to the rest of the topics. Chat. Andrew is asking if we're involved in aviation safety compliance. That is a fantastic question. As you'll see if you log into our website, we've actually done some FAA DO-254 filings for a couple different aircraft component manufacturers. This isn't a huge focus within our company, but definitely something we spend time on. We spend a bunch of time, for example, trying to work with Part 107, the emerging Part 108, whatever gets published, and the new stuff for drones, autonomous aircraft. So some really fun problems there. But as a company, we go where there's commercial draw, and we've had a lot more traction in industrial and service robotics than in aviation. So that's why we kind of have the focus of advertise. Hope that answers your question, Peter. Go back to manual work really quickly. There are a few different categories of this work that we'll talk about. The key is a bunch of analyses that need to get done both by humans as an input to the system. I see one more chat. I'll hop over there in just one sec. And stuff that can also be done by these automated systems themselves when appropriately constructed. So that is part of that tool use piece of the story that I'll share with you guys later in the conversation. Okay, let me take a look at that one. Lou is asking, are hardware standards and compliance requirements more the focus currently than software standards and compliance? That is a very, very good question. So I'll divide this into two buckets. There is one space of software standards and compliance that is really, really common here in San Francisco. So maybe you guys have come across these companies like Vanta and Drata that are really proliferated in the software as a service, cloud software world to help people get through data privacy and security certifications like SOC 2 and NIST certifications, all this kind of stuff. That particular market is really, really well served. There are a lot of companies there. These companies have grown really well. They've actually created a great standard for how we build our business. We see the complementary part of this, which is both the hardware and software components of physical products as the most important place where we have a lever to pull. Something unique that is a big problem in the industry that people are looking for solutions to. So hopefully that gives you a sense of where we sit as a company. One interesting thing you'll find when you dig into functional safety standards, for example, is that a lot of their focus is on software behaviors. Hence why IEC 61508 focuses on programmable systems, and for the most part is used to validate the software that you write. Though there is a fair amount of hardware discussion. And that's exactly what you find. A lot of the complexity in new products where there's ambiguity, where there are unknowns, where there's a lot of opportunity for us. That's where it focuses. So it's a really good question, Lou, and it's kind of I have no idea if I give you a good answer, but hopefully it was some context. Okay. This is a kind of trite statement, but our goal as Saphira is to streamline every piece of this process. We want to streamline the analyses, the understanding, component tracking, NRTL reporting, and tracking of everything else in between, your requirements, your progress, your iteration. How we do it? The biggest idea, and this is where we really bring ourselves back to what we're going to present today, is to intake unstructured information, all kinds of data like general descriptions of your product specifications, data sheets, market information, end user information, environmental information, in the format of schematics, CAD, data sheets, Excel sheets, BOM, simulations, basically anything. The goal is to be able to provide feedback on every one of these domains of information. And that's also where we think there's a really exciting opportunity for agents, because we no longer rely on integration bottlenecks of different APIs to be able to bring software together, right? So we as systems engineers, we as people that are designing systems, have a whole bunch of different ways to represent our products. And oftentimes they're non-interactive. So today, because of some of these data transformation tools, we're able to bring all of those together. And that is why we're able to tackle this in a context-driven way, along we'll discuss throughout this conversation. I have a slide that we typically go through about the Saphira V model. I won't really dig into that because most of this is not going to be covered today. And a lot of the composition of our dashboard, also a little bit less relevant, stuff that might be exciting to those of you who do machinery safety work in the room. And if it is relevant, we'll have my contact info and everything at the end. So definitely shoot me an email. This is what we end up producing. These are all the different actions that we support. We have open-ended mechanisms to select standards. For example, this is an example of a generated questionnaire that we pose to producers of particular robots. It asks different things about their application, about different properties of their system, and uses that to identify particular standards that apply. That's right here at the end. So you can see, for example, the reasoning for why 62508 and 13849 apply to this particular industrial robot. That is all a piece of this big puzzle that we're going to talk about of how you build agents that can guide you through this whole process, but in particular, that can develop requirements for you. We have something similar that can just parse open-ended input, but this will be an example we'll come back to later in the presentation. Skip through it. There we go. We surface a bunch of raw information and parse information. Value proposition, not super focused here. But to wrap up the introduction to the presentation, the last thing I'll say is that the industry as a whole needs to adopt AI to speed up compliance. We all know this. That's exactly the goal of the Drive. I see a couple chat. Andrew mentioned that's a lot of proprietary information. That is a very, very good point, and definitely something we'll talk about probably in questions towards the end. There's a bunch of really cool stuff that we do to manage proprietary information in secure ways and allow users to do this processing directly within their systems rather than actually sending anything out to us as a separate entity. So a huge focus, and totally agreed. This is exactly a problem we hit in many of our production deployments. All right. Lou made an excellent statement here. Today's systems are more and more software intensive, with software embedded in hybrid hardware software systems. Safety and security and resilience must be addressed holistically, focusing on the integrated system behavior and emerging properties. Sadly, standards and regulations seem to still put hardware and software in silos and don't address the system from a holistic perspective. 100% agreed, Lou. This is a huge problem and a huge driver of our work because interpreting many of these standards for cases where you have software control of safety properties can be really, really difficult. And that's what we try to make really easy. I think a little bit really tangential to a lot of the conversation today, but a topic I'd love to come back to if there's interest. Okay, so back to the crux of our presentation. Why do we apply agents for requirements? And what do agents even mean? What are these systems? So let's start with a couple of problem statements, and then we'll start building back up to a thesis for this presentation. So requirements are often vague, incomplete, and fail to capture downstream impacts. That's the kind of problem that we believe can be tackled well with context. That's going to be a big focus that we will have today. The second piece is that manual creation and review of requirements, especially safety-related ones, are tedious. That part matters a little bit less, but error-prone is the piece we really, really care about. We need to make sure that all the right information is considered and that mistakes are not made. That is the biggest challenge to that we try to solve with agents, and it's also the biggest problem that we have left with agents. So that's a lot of what we'll talk about today. Now, building back up, the third statement we have on this slide is that agents can augment engineers by surfacing context, suggesting revisions, and linking to relevant analyses. That's kind of a statement of what we're going to work towards. But let's really quickly in between define what agent means. So when we talk about agentic AI, the idea here is not just LLMs alone, not just LLMs as chatbots that you interface with, but LLMs that have the ability to perform programmatic actions out in the world, quote unquote. So in our world, a lot of what that means is that we believe that the most important thing you can do to properly use LLMs is to guide them to collect all the right information at time of inference. So we'll talk a little bit about how we do that in just a minute. But this also extends to how we actually produce all the linked analyses and artifacts down the line. A big point of conversation this morning, a question that was asked was, one of the biggest problems in many of these compliance exercises is that a lot of information about products is just not known upfront, right? So part of that becomes a question of how can these agents prompt users back for the information that's missing from their cases. But the second piece is also how can it go and find it on its own? How can it consider unstructured information it has access to and break down that information, analyze it in structured ways, the same way humans would to collect the information it wants? And that's a lot of what we invest in, a lot of what we talk about today. The main thesis of this presentation is going to be that agents are only as good as the context you provide them and the structures they can work within. And so what hopefully you'll come away from this presentation with is a sense of how you'll actually go about building context going forward, both when you directly use LLM tools and when you build LLM tools or use tools like ours, and how you actually make sure that that is correct, comprehensive, and representative of the most intuitive form of execution of these workflows that you as an expert understand. Hopefully that prompts the conversation well. First section of this. So let's first talk about when we say context, what we're referring to. So we break this into three categories, and we'll talk about structured context. So information that you guys have a ton of experience creating. Things like SysML diagrams, spreadsheets that are representative of analyses, bombs, so on. Past requirements, that's a huge, interestingly structured artifact that you guys are all very familiar with. And standards, that's really the focus of a lot of our work, and was this morning of a lot of the conversation too. Now, unstructured category actually includes a lot of the above, right? A lot of these artifacts come in the form of PDFs, of slide decks. There are associated artifacts like lab notes and design reviews that are also critical to have the right human input to making sure that the system produces the right outputs. And what we'll see in a minute is how we can intake all of this information to tell a clear story about how to iterate upon and first generate requirements for a product. Okay. The last category of these items is multimodal information. And this is a lot of what we will have a chance to demo later today. We have items like block diagrams, wiring diagrams. You can even think of this as related to SysML from above, but there are all kinds of diagrams that you guys create that are not necessarily well represented in SysML or in other structured formats. And so we want to be able to interface with those really well too. And that's a lot of what we'll show in a minute. Tables, natural language, a lot of the really challenging pieces of these existing artifacts like standards to work with. Okay, so to frame the problem statement a little bit, let me describe really quickly the origin of this problem that we worked on, of risk assessment citation. So before we even get to the point of having requirements that we're iterating on, a lot of where we started as a product was figuring out how we can inject the right information into a risk assessment. What are the main origins of requirements for safety critical products, especially in preparation for certification? So let me walk through this demo really quickly. I'm going to mute this and go in full screen. I'm going to skip through, and I'll show you a little bit of what comes into play here. So we're going to create a new project in this demo for a robotic system, focus on a safety case. And what we're going to do is we're going to answer some questions about this product, such as whether it has SRPCSs, so on, in order to populate a couple things. One is going to be the first set of hazards and controls that are analyzed for a product. And the second is going to be relevant context within the project. So first, when we look at a project that's generated, you'll see a few of these initial suggestions of very high level, very trite hazards that are exemplified. But this is where the context is actually enumerated and where things start getting interesting, which is that when we suggest that you should start by looking at component failure, the first thing we guide you towards is where in ISO 13409, one of the main machinery safety standards that we work with, there is discussion of how you go about categorizing your mitigation to a component failure. And the reason for this is 13409 discusses how you build safety functions. So the main utility is going to be, we are now going through a process in our platform of citing some hazards and then generating some controls for those and making those suggestions back into your design process. So you have requirements input, and we want to make sure we have all the right guidance for that. So the guidance that this was automatically able to retrieve was that, okay, you've defined some component failure as your starting place. Your task is to create a control for this. The thing you should probably be looking at to begin with is the different categories of safety functions that 1349 lays out. So it fetches page 78, among a few other pages, makes a recommendation of, hey, this particular clause within 1349 is going to provide you the information you need to do this job. So that's example one of how you retrieve the right context to guide an agent that will take you through the earliest stages of requirements development. So first example, and I saw a chat message right along the way here. Andrew asks, component means a physical physical object, device, or system. Very, very good question. So when we think about components as we represent them in a platform like Saphira, we treat this generically. So what we try to do is build a hierarchical representation of a product and its environment. And so when we say component, we will actually mean each of these different things at a different moment in the analysis. So that's later in the presentation when we talk about when you make this a properly agentic process and you have a system that just continuously runs through every piece of the system all the way up and down the hierarchy, then you start making a really key differentiation between physical objects, devices, and systems. But in the meantime, we kind of populate this information directly based on what the human needs at their time of use of the system. I don't know if that's a good answer to your question, but hopefully it gives you a sense of, we aim for this to be generalizable. And so we think of components as a flexibly defined concept within a system as you can represent. Okay, so we quickly discussed retrieval of norm information and inclusion of that in derivation of a control, which is going to be one of the suggestions into your initial requirement set. So that's going to be right down here. And you can see that for self-validation verification, we will suggest something similar. But actually, what I'm doing in this particular demo is that we're actually going to import a few more hazards. So these are known hazards that you'll see in just a minute for this type of system, such as in normal operation, the shuttle guide rollers for this robotic system may have inadequate shielding on the guide rollers, creating a pinch point risk for operators performing maintenance. So you can see here that an engineer has already defined a hazard. We're importing a hazard as a starting place in developing these controls. So that's the first thing we're going to do. Before I continue, I see a few more messages. Lou asks, can we think of a component as a system element, which can either be hardware or software? 100% correct. So the idea is that this will be clearest when we go through the example in a little bit of FMEAs. But as you well know, when you build a VDA compliant FMEA, you're going to have focus elements for every failure mode that you consider. And that means that the focus element can be at the system level, at the component level, or it can be at a subcomponent level, anywhere in between. And exactly as you said, these elements should be able to be any of those so that you can introspect your system as deep as you want or treat as high of a level as you want as a black box for pure analysis. Andrew continued this by saying, for example, a software component might be a binary that runs on some hardware platform. Totally agree. So exactly as you can imagine, when we think about component failure, typically what the agent would do after that initial proposal we saw a minute ago is it would ask you some questions about which components you want to analyze. Or when you set it off autonomously, it's going to go through and try to identify every one of these until you define some boundaries for the system. So that's a lot of what we're working towards as a company. Hopefully we can teach you guys how to build in this kind of conversation. Okay. So we have a few of these hazards. We have prospective controls that are already in place. So when we import all of this, you'll see all of this gets populated. And along the way, for really specific hazards that we present, we actually immediately retrieve the relevant standard sections, such as when we discuss tray jam misalignment, the immediate recommendation when we go to try to come up with additional controls is that from 1349, you're going to have to look at specifically category 3 safety functions. So what it's looked at in that is it's thought about every intermediate piece. A lot of what we're going to make really literal later in this conversation. So how severe is this particular hazard? What is the required performance level for an emerging safety function, and how are you going to design it? And then it goes and tries to retrieve all the definition information for that class of architecture that we're going to use to put together this final requirement. And so that's what it puts together, and it's able to tell you how to interpret that. Now, this also becomes a little bit more useful when you add more information. For example, we have here a new textual requirement that was added, which is going to be another hazard, power supply failure. And when we add this, we are able to go and retrieve even more context and get some different pointers. So for example, the place where power supply failures are referenced in a note in 1349 is actually with reference to category 2, um, uh, uh, category 2 safety functions. Because typically the way that this particular hazard is stated is not something that would be a sufficiently high required performance level to mandate a category 3 safety function. So that's the guidance that we fetch and include in the next artifact, which is going to be to generate one of those controls. So we come back to wrap up this demo to the most generic way to interact with all this information, which is that you can even prompt an agent very generically to go and fetch you all the relevant details. And that's what a chatbot is great for. But it's also where we demonstrate the ability to go a step beyond what, for example, a ChatGPT will do, which is that you can actually configure this chatbot in a wide variety of different ways. You can tell it, hey, I need to go look at every one of the 500 pages in the standard. So aggregate all of that into your final context and make sure that your final answer considers everything available. And so then it sends it off on a task that'll take 10 minutes or something like that and process every one of these artifacts and bring you back a comprehensive answer. So you can start to see how the configurability and guidance becomes useful in building the full story. Okay, I think that covers the basics of what is present here in the origin of this problem statement that we have, and hopefully gives you a little bit of a sense of how we start building up a plan to derive the right context, package that in for individual tasks, and ultimately send an agent that's responsible for creating and reviewing your requirements off on a journey that's well structured for those tasks with that context to actually do what a requirements engineer would otherwise be doing, or a systems engineer would otherwise be doing. Okay, so let's move on from this one a little bit and quickly touch on what agents actually do with this context. So this is where we start getting in this conversation about tool calling, which is that what we want the system to do is not just interpret this context in raw ways. The analogy that we make is that when you think about using one of these AI tools, a lot of what you're doing is you're not setting off a computer program to do some deterministic action. You're thinking about how you represent a task in the same way that you would to, for example, a really junior member of your team, someone that has no idea how to do the job that you're doing. Maybe they'll come up with some arbitrary way to do it, but if you let them come up with that, they'll probably choose the wrong path. So if you create the right path and you create all the intermediate understanding that you need, then what you actually get is the right chain of thought and the right augmentation of retrieval that lets you provide the right information back to the user. Okay, there's a chat message here. Andrew made a fantastic point. 100% knowledge at this stage might be an unsafe assumption. Does your tool allow updating later upon new knowledge? 100%. That's a lot of what we'll get to in just a minute with the next section of feedback loop capture. And I think this might actually be the right place to start taking some of those prompts and jump around a little bit in the conversation. So I might do that in just a minute. Yeah, I think this might be a good place. So I think I'll come back to this example. The example I was going to give was going to be given some additional incremental information, how can you iterate on a starting place of a requirement that you are presented? And so we'll come back and we'll show that example in a minute. And actually, now that I think about it, that example might actually tackle Andrew's question pretty well. So what we'll show here really quickly is what I've done is I have an autonomous vehicle project where I've seeded some really high-level template requirements for an autonomous truck. So you can see here, for example, that I have prompted, I've seeded in this project an initial requirement for the safe stopping distance of the truck. So a really canonical thing that many people will put together early in their safety concept. This is a kind of difficult requirement to derive, but that's why I'm starting by deriving a different requirement from this. And that's what we'll show this demo really quickly. So the chain of actions that I'm going to go through is laying out the chain of actions that we'll often want to hand over to an agent to perform autonomously, but every step along the way is going to be performed by intermediate agents in this case. The first thing I'm going to do is starting with ADSR2, that system requirement regarding stopping distance. I'm going to tell the system to suggest the task that the truck is performing at that time. And what I'm going to use this to do is generate a hazard table that we're going to use to iterate on this top requirement, which is the minimum obstacle detection range of the vehicle. So you can see some tasks that were suggested, things like universal application of a collision detection system to ensure collision prevention. We'll see where that plays in just a minute. And the one I think we're going to choose is going to be, from that requirement, the task that may have influenced some of this is the task of automatic braking when an obstacle is detected. So that's exactly the kind of information that helps feed the upper requirement, which is, okay, if you know how much your safe stopping distance needs to be, and you know that the task is to automatically brake if an obstacle is detected, then you start to have some information about how you'll actually go about defining the minimum obstacle detection range. So that's what we're going to try to do. So we have this task, auto brake activation. And we're going to go into that one task and we're going to retrieve some identified hazards. And one of the cool things you can do is you can actually point this towards specific standards that enumerate this class of hazards. So for example, we're doing some work in autonomous vehicles, and there's some really nice new SAE standards and a couple of emerging ISO standards that actually have long lists of possible hazards that could occur with this kind of task. And so we're able to refer to artifacts like that for these particular projects by enriching them using them in the given project to qualify. So you can see some of the hazards that are suggested: false positive braking, false negative, no braking when obstacle is present, and environmental factor interference. And all of this is providing fantastic guidance to go and iterate on that first requirement. So what we're able to do is first, we link together that initial requirement to all of these hazards. So we're saying that we need to influence via this parents linkage, this requirement by all of those. And once we've done that, we save that and we go and I paused a couple times. We associate some more information with this requirement. We're going to associate a block diagram of the overarching system. So you'll see that in just one sec. That's right here. It's a really generic block diagram. It's not really specific to this requirement, but it's relevant input for this consideration. So that's what's happening right here. You have some sort of block diagram that illustrates feedback loop between the steering and braking and the engine controller. Really, really basic, but something that can give us some information about how to consider the architecture at play here. And then once all this is present, we go to our copilot in the top right, and we describe how we want to iterate on this requirement. So we say, for example, we want to update the value of this requirement based on the linked block diagram and the hazards. And the cool thing is, all of that information is stored. So now every time you go and perform one of these activities, including for the linked artifacts, you have that trace of what you need to consider. So now you have a guarantee that many of your actions will take into account the proper context. So again, honing in on the main thing that we try to hammer home is context is really, really critical. And building your context, maintaining your context, reusing your context is the best thing we can do to build a sustainable agent. So you can see that the result is that we bump up this vehicle minimum range obstacle detection number. We say it was previously 100, now it should be 150, because there's actually some difference in how we are considering all of the failures. There was a discussion earlier of one of the hazards from the task being environmental factors. So when it thought a little bit more about environmental factors, it was like, wait, listen, there are some environmental factors which actually create more interference at that initial range. So if you optimize for longer range, you can protect against some of those. So now that you're considering this, you have the trace of your motivation, right? So you can automatically understand what that motivation was and why you're iterating on your requirement. So idea again being that once you have all this context, once you link it all together, once you build a clear structure, then your requirements agent is able to do the same job you are doing with the same information you're doing as the new information is associated and interpreted and edited. So you can build basically a reproducible version of your own mental model of how this work is being applied. and use that to get recommendations of how to change your requirements. So I know many people that talk about requirements, feedback, and iteration in RWG focus on like the syntax of requirements. This is much more focused on the semantics of requirements, and that's what we try to show here, where that can properly be captured and map back to development criteria you'll want to use them. And it's everything I wanted to show in this particular part of the demo. So let me hop over to the question. Okay. Andrew asks, a healthy child running for whatever reason towards the front of my oncoming truck would dramatically reduce the safe stopping distance. That is very, very, very true. And so this is one of the biggest facets of the work that we do with certification for many different kinds of products, which is defining the operating domain. Right. So as any of you who've worked with ISO 26662, 21448 know very well, one of the biggest problems in modeling these kind of systems is there could always be low probability, extremely high severity problems that occur, such as a small child running towards the truck and violating that safety distance. So how do you handle cases like that? Well, the truth is that when you first start using a tool like ours, the first thing you need to do is you need to get input on what that initial scoping is. So while a lot of what I've shown here is filling in that initial evidence, the requirement, the hazard, the task, every one of these intermediate pieces, there also end up being a bunch of other key pieces you need to fill out, just like that questionnaire we saw a minute ago for robotics, such as how do you define your operating domain? Is this actually an acceptable piece of your operating domain? Or for example, you're building an autonomous truck, it's only operating on the highway, and therefore there's actually not a necessity designed for frequent exposure to pedestrians. And therefore, because that's not something that most human drivers on highways at high speeds are handling, then it doesn't necessarily need to be something you're explicitly designing for. But in truth, what you're actually saying, Andrew, is a huge piece of the value that we provide to many of our partners, which is that we go in and we say, hey, there's going to be some missing stuff here. Let's set out this agent to go and explore the undefined space of what could occur. And so we put some parameters in to define what those low frequency, high severity cases could be and help identify those as drivers for our requirements. So I have no idea if I answered your question, but we try to frame that as another best effort problem that can be tackled with this kind of system. And again, the way we do that is by, again, backing out of the mind of a safety engineer, right? So what we're trying to do is replicate to best ability what an engineer would do. And in truth, there's some of these things an engineer could never do. So can we, by making what an engineer would do as repeatable as possible, just extend their abilities? And that's where the value of a tool like this comes in. And the value of this class of tools, the kind of things that many of you are likely building or using. Lou asked other factors like braking force, time of applications of that force, tire size, characteristics, road surface, changes in your environmental factors, black ice, all super, super critical to consider. And so what you see here ends up being just the starting place. The idea is on a continuous project, as we'll see, all of that information will be prompted back for in defining a more and more sophisticated OTT. So we started the conversation on tool use a minute ago in the context of analyses, right? So this idea that when you are identifying each of those different inputs, like Lou, like Andrew were suggesting, there need to be structures for how you do this. And so that is a big piece of what we try to drive. We try to create structures that model, again, what a safety or systems engineer would be doing in order to build the understanding of the world they're contributing to, exactly what Lou and Andrew were saying a minute ago. So these take many different forms. They take the form of, for example, HARAs. They take the form of FMEAs. They take the form of FTAs when you're trying to understand cascades of these particular issues. And again, the emphasis of this presentation is on this topic of context enrichment and how you can provide the right details at the right time to be able to perform these tasks best. So that's what I'll focus on really quickly before hopefully jumping over to a few more questions. So the problem statement we've laid out for example, for a HARA is that our goal is to identify system functions and corresponding hazards. We want to, for example, for an automotive system, estimate the ASIL based on exposure severity controllability, and we want to flag missing mitigation paths. So kind of all the stuff that was briefly mentioned earlier. And the way that we want to do this is by considering as open-ended of information as possible. So one way that we try to do this, that we recommend to many people as something to explore, is to take dynamic representations of flexible design you have as part of your product. So we give an example in this demo of a CAD model. So I'm going to meet this again, and I'm going to scroll through this a little bit. You'll see a small household robot that we were using for a demo. It's an old product from Amazon. Some of you may recognize called Astro. And what we try to do is we try to take flexible definition like this and boil it down into standard specific citation of specific classes of hazards. So for example, when we click in just a minute, you see that when we try to use the ISO 13482 approach for analyzing the image of a robot that was provided, there are going to be two classes of hazards that are most important to identify. There will be those due to robot shape and those due to contact with moving components. And what we've been able to discover and prove at Saphira is that our vision language models, the standard ones that are available on the market, things like GPT-4o and Gemma 8B, the local one they use for private deployments, they're able to interpret these statements fairly well, especially when given enough examples and enough guidance. Again, trying to clone what a user would otherwise be doing independently. And so you'll see how the system does that in just a minute, which is that it'll intake it and then define a sophisticated structure for output. So we expect that every output comes with context, assumptions, and then really interestingly, highlights. So for example, you can click in here and actually see all of the bounding boxes that 4.0 recommends for where particular issues might arise with this type of product. So when considering all the locations of movable parts, it's able to highlight that it's this segment of the moving neck, the screen, that might cause an impact hazard. And that's one of the key things you want to assess. And the first bit was moving issues with the wheels that could cause, for example, a user's hair or fingers or something else to get stuck in the system and thus create injury. That is something that is highlighted here as well. And so what you can see here is that when you create enough structure for the agent to output and you give it all the right context, then it's guided to performing the right task and operating at a level of granularity that is difficult without knowledge. So the goal is here to be able to present something that contributes that insight to any team that is building up these artifacts, whether risk assessments, FMEAs, or similar. So we do the same here, but then really interestingly, we can do the same with CAD, as mentioned at the beginning. So what you can see me doing here is I'm uploading a step file, so a canonical CAD export that is, if I remember correctly, dimensionless. And the result is that we are able to take some initial viewpoints on the model. But the really exciting piece of this is actually, again, capturing tool calls out of the hazard identifier. So as you go through this hazard identification exercise, one of the tools that this agent has access to, and when we say this, we mean this in the form of we implement our agents using tools like Love Index, and they offer tool function classes that you can implement that lets you, for example, make requests back for different views of the CAD model. So what that creates is an internal feedback loop for the agent to cover its gaps of knowledge and go back and retrieve additional information that was not already present in this corpus. So that goes a step adjacent to and perhaps beyond one of the points that Andrew was making earlier, which is this idea that you want to make sure that as your agent is performing one of these jobs, it is building both its knowledge of the world, the product it's working on, its environment, its application, but also it has a way to go and fetch more information. And so that's one of the most important things that we believe is critical to enable, that actually gets us a step beyond what these core LLMs are able to do, and to a point where this agent is able to make concrete recommendations to the requirements that you adopt for your product. So yet another piece of it. I do want to make sure that I saw if there are any questions. Otherwise, also anything.
Yeah, Akshay, this is Prabhu. I just have a couple of questions. Have you done a proof of concept by any chance of going the reverse route, which is, let's say for a system or subcomponents of a system, you identify all of the relevant standards, whether it be IEC, ISO, and then you, based on what you know you have to comply with from a standards perspective, it backtracks and regenerates the risks and the requirements and spits out the requirements as opposed to us trying to guess. Now, of course, requirements are very complicated. As we know, we have tolerances, this, that, I understand all that, but I'm just trying to see if that proof of concept you went the reverse route, and if you found any insights there.
Just so I understand the statement of reverse route, the idea that you're trying to say is that, okay, you already have a definition of the product, but you want to introduce some standard to govern the product, and you want to iterate on the requirements based on that standard. Do I understand that correctly?
Yeah, like I might be building an electromechanical medical device, let's just say as an example, but I know that 60601-6 or 1 might be relevant, and then there's also some other mechanical standards, even cybersecurity standards. So if I put in as an input all of the even at the clause level, let's say, that does it help me going the other way to generate the proper set? Because I know what I have to comply with from a regulatory perspective, trying to take some of the guesswork out of the risk and the design input side of it.
It's a really good question. And in truth, all of the work we do tries to replicate exactly what you described. But it's kind of unfortunate as a result that I don't have a perfect demo of exactly that in the deck. So give me one sec and I'll try to actually shift over to the application itself and take you live through, I think, the sort of workflow that you were describing. The example that we were sharing earlier was that we have a palletizing robot that's defined in our system. And one of the core views in our system after you've done that hazard identification is this frameworks view, which is a broken down version of every one of the standards that we've associated with your project. So, for example, actually, let me see if I have 60601 already loaded in here. And if not, I might have some other medical standards. Okay, the only one we've loaded is 13485, which is a little bit different than quality management standards.
Yeah,
so not super relevant. So not super relevant here. We've done a couple of 60601 projects just outside of this exact view. So I'll use 10218-2 as an example. So the idea here is that when you dig into 10218-2, what the system is able to do is it's able to, for some requirements where there's explicit statements, make a compliance check and then recommendation based on whether or not it seems like you're already complying with these standards. So for example, we have a bunch of details in place for this palletizing robot. Let's go back over here. I'm in another tab and I'm just going to pull that up. I'll show you some of the details we have present, which will be details regarding some of its compliance, some basic properties of the product, and then really an initial set of hazards and failure modes and so on. So a big structured pool of information. And what this system is now doing in the background is it's reading all of that and it's reading any associated documentation. And it's saying, from all of this documentation, does it seem like you're meeting these really basic requirements? So some sections of the standard are really high level. They're saying things like, the integration parts shall comply with this part. Okay, so that's just the scope. And then there is some statement that there are, the cell must be designed according to the principles of 1200 for hazards that are not part of 10218, such as sharp edges. So you can see there's an expectation that there's some consideration of additional hazards that were not already considered in a basic case, assuming that, for example, you're using a 10218-1 certified arm as part of your line. So that's exactly what the non-compliance suggestion ends up saying up here. It's saying, okay, based on all the document that was present, it doesn't seem like you're meeting this yet. And here are the steps to make sure that you provide all the right data to indicate that compliance. So for example, it's going to be, hey, you need to conduct a comprehensive risk assessment to identify additional potential hazards, focus on fire, electric shock, and explosion. So the key things that are not covered by 10218-2. So we're able to make recommendations like that. and ultimately produce for you a checklist. Let me actually see. I'm going to try refreshing. We just shipped that to-do list on some standards yesterday, and I'll see if that's available to you. Otherwise, I'm going to ask Oscar right next to me if that shows up. I think that is a pretty cool thing to see. Okay, it doesn't. Shoot. Okay. But yeah, one of the cool things that we just shipped the ability to do is you can take a look at a to-do list checklist that says, hey, we ran this compliance check across the entire project, and here are all of the reevaluations you need to run. And many of those are actions that the agent itself can take. So for example, you can say, hey, I specifically want to go and rerun part of this risk assessment. So you click a button and it goes and redoes that and requests additional information of the product where appropriate as regards fire, electric shock, and explosion risks in this particular context. Does that answer your question, Prabhu? I don't know if I properly walked through the cycle, but hopefully I illustrated bits and pieces we've done.
Sounds like there is scope for going the other direction as I was thinking. One other quick question, and then I'll stop. I was in a conference recently where I'm in the medical device industry space. So it was made known that the FDA, for example, is going to be using AI-based tools for submission evaluation. So one of the things that came to mind is, so if a particular agent structure is used, have you been in any conversations that says, okay, if you're using an agent that works this way, like what you just showed, for example, what aspects of it have to be identified as relevant to the submissions? So this might be not just for medical device industries, but it might apply to other industries where agentic use is being utilized, but then if how well does it align with that industry's body's evaluation if they're going towards AI, and what part of the agent is going to actually be relevant for the device manufacturer to point out to say, I used it in this way in order to be compliant. Any thoughts on that front?
It's a really, really good question. I don't have a good answer on this. The best thing I can say is that, as you can see, we as a company have mostly worked in the industrial machinery space. And the main certification bodies, as you've been familiar there, include UL, TÜV Süd, TÜV Rheinland, a bit of work by Intertech. And so one of the biggest things that we invest in as a company is making sure that we collaborate really closely with these certification bodies. So of course, they're not quite regulators, but they act kind of like regulators. And the interesting thing is most of them are not yet at the point, like the FDA, where they're actually using some similar tools to vet submissions, but they all have a vested interest in making sure that the submissions they receive are providing the easiest format of information to work with. And so that's a lot of where we've been trying to spend time of actually starting the kinds of conversations you're describing, and seeing, for example, the idea that hey, the parts of the agent that may be a little bit less relevant are, for example, internal artifact development. So, for example, while your technical report for a robot will always contain some version of your risk assessment, it will not necessarily always contain any of the FMEAs or similar that you've run, because those are proprietary pieces of information. And so one of the things that we've been trying to see is, hey, what if we can prune out all of that, but leave just the artifacts that are actually being reviewed, carve that piece of the agent out, make that even more interpretable and visible to these stakeholders, such as a certification body? Does that enable us to, for example, even get certified to use a product like this by the certification body? And then on top of that, endorsed by a body like that. And so it's all stuff that we've explored, and we haven't really figured out as a company. So I guess part of where I'm going with this is I really love to connect after this meeting and talk about getting in touch with some of these FDA folks, because I think those are at least the people we should be learning from and figuring out how to integrate properly. So thank you a lot for that prompt, and something I'll look more into.
Sounds good. Thank you.
Sweet. All right. Looks like the questions are flowing in now. So 6 questions. Let me scroll up to the top and take a look. So there were a few messages by Lou. So standards and regulations have requirements on the organizations developing the product, as well as requirements on the product itself. How do you differentiate and handle these types of requirements, these different types of requirements? That's a fantastic point. And this was a question that Lou had asked this morning, and I hadn't gotten a chance to answer, so I do want to prioritize answering something like this. So what you'll see is that that's exactly right for what's being laid out here. For example, the way that that this one scope quote unquote clause, which is not really a clause you can use in a compliance case from 1028-2, is discussed by the system in such a way that it's clear it's considering it from a procedural perspective. Furthermore, every one of the risk reduction and hazard elimination clauses, again, primarily tackle the actual procedure of risk assessment that a company is running. And so what we try to do is we try to ensure that all of this information is picked up wherever possible and considered on as much input data as possible. I don't know if that's quite the right way to say this, but the way that I think about this is, how do I say this? There's certain information that you can look at the product documentation and make statements on. That's going to be, for example, all this below requirements. And there's some information that requires you to consider the metadata, who is performing something, what sequences is happening, and so on. And so we try to model both as different activities that take place within the platform. And this is a big thing that we've been trying to figure out the right way to automate, but right now I've been kind of splitting up manually. So, for example, everything I've shown right now, when you run that automatic clause analysis, you get that pop-up, you have a way to upload evidence and iterate on that particular statement until the system marks you as compliant. That's all fine and dandy. But the way we actually apply procedural validations is often through a different segment of the product that I actually have a good slide on later here. So maybe I can scroll over to that and show you a little of what comes up there, which is our mechanism for not diagrams, not automated grouping, but automated checklist review. So one of the ideas here is that what you might do, we should put this, you may have defined, for example, this is again that autonomous truck project, some particular procedures that you want to validate an exercise by. So what we illustrate here is that there's a way to build that up as a separate structured task within our system. So by default, we, for example, have this. All right, I guess I didn't really configure that in this demo. But what we have created in the settings for one of these projects is a custom checklist that is down here. So shows up right here. That is derived from the VDA 26262 assessment guide. So exactly one of the things that would feed into procedural compliance versus product compliance. And every time an associated artifact with one of the governed components is input into the system, so that's either fetched from externally or input manually by a user, we provide feedback on whether every step along the way is being met. So for example, we've imported every one of the items that needs to be checked on a software design document. And what I've done here is, an example, was me actually uploading one of my design documents. So we're not building 262 compliant software. So my design document was missing a whole bunch of stuff. And the system was able to tell me exactly what and why. So you can see here, let me see actually if it did. Okay, I think to begin with, this demo just showed me going and putting all of these, where it came from on that assessment guide, and then the actual document. And in the mid, there you go. There's the justification. So it says, okay, you did not meet the requirement to describe the overall software structure because you did not yet integrate explicit architectural design content. So kind of trite, but should be pretty obvious if that content is present. So this is one idea of how you carve out process questions into a separate activity that an agent is performing, and then make sure that that's assessed against a different set of artifacts. For example, the artifacts that are actually governed by that particular process, such as your risk assessment or your design documents, not necessarily specific requirements, specific criteria, specific. No idea if that was a good answer to your question, but hopefully that started off the conversation. There are lots of considerations when addressing compliance with standards and regulations. The RWG video on standards and regulation compliance can be viewed on the INCOSE RWG YouTube channel. Thanks, Lou. Fantastic. Yeah, and there was a fantastic point Lou had made this morning that complying with safety and security standards will not result in a system that is safe or secure. And that is a huge piece of what we try to focus on as a company, which is that we try to figure out where there's more work that should be done. So it's a step beyond compliance. It's a step towards actually understanding the fundamental safety of products. And so that's the beauty of grounding so much of this work in artifacts like risk assessments as mandated by so many standards. This idea that you can keep on digging, that there's always going to be residual risks, and there are always going to be further recommendations you can make to further bring down the residual risk. So our thesis on all this is that one of the best things that agents give engineers time to do is continue iteration, to keep on moving on cases where you've gotten to a place you're pretty happy with in terms of compliance, and you've gotten a certification for your particular safety functions in the product, but there's more you could do. There's further mitigation, there's further lives that can be saved, and further injuries that can be prevented. So I'm going to try to drop. Okay. Andrew asked, is this kind of requirements analysis intended to be iterated over the projected device/system lifecycle? AI tools are continually evolving, and an assessment that appears complete might be viewed later as incomplete. It's a really good question. And I think our value proposition as a product, as a company, is exactly what you described, that this is an ongoing activity. Not only does whether an assessment is complete continue evolving, but furthermore, even the question of how your product is evolving continues being one of these questions I can ask. And so we see a big utilization of our product suite as monitoring that design evaluation. Monitoring that design iteration. So looking at changes that are made to products and making comments, providing feedback, and saying, hey, this was the way we understood the trace into some compliance case in the past, into a risk assessment in the past, and it seems like that is broken. How do we fix that? Here are some recommendations. So addressing that.
My question is, acknowledging that one document often will reference another document, hey, you have to adhere to the standard, and that standard will also call out another standard, and so on and so forth forever. Is there a way to limit that sort of recursiveness?
That is a very, very good question. And that's kind of the inverse of the first statement we make on this. So one of the things that we briefly glanced at in our platform earlier is this idea that for a bunch of these requirements, let me go over to local to show this a little bit better. You can see, for example, 5.2.1 and 10.2.8-2 references a whole bunch of standards. 13.4.9, 10.2.8, another section, 62.061, so many different standards. TR 23849, exactly as you said, the first place you can start is that you can generate tool calls off of all of these to, again, populate context when assessing a requirement like this or a clause like this from the standard. So we illustrate that in our UI by actually showing that particular tool call right here. So the first thing we did when we implemented something like this was we didn't try to tackle the recursion problem. We instead tried to create a context for recursion until you reach a baseline. And actually, I'll tell you about the use case that inspired us to do that to begin with. So one of our users is an EMC consultant, and he works for a big consumer commercial aerospace manufacturer, and their EMC testing, when they construct their qualification test plans, is first influenced by DO-160G, as everyone in aerospace is EMC testing. But then there are a series of internal standards that overwrite requirements from DO-160G. But every one of those overwrites typically either is idempotent in itself and is acceptable in itself, or continues making references to some chain of documents that ultimately lead back to a standard. So what we tried to create was basically these different termination cases for the search that the system does. So we say, okay, record your path, just like in a breadth first search. If you're trying to do cycle detection in a potentially cyclic graph, record the path you've taken. Make sure you don't backtrack and don't end up in a cycle. But as long as you're being led to new documents or new sections, keep on following that path until you reach some source document. So, for example, in the QTP case, actually, it wasn't even navigation between the internal standard, the external standard, and the QTP that was most important. It was actually, hey, one of these might actually go out and search on the open internet, and then if it reaches the open internet, then there will again sometimes be citations to other resources that you can follow, and sometimes citations all the way down to the standard. So we said, okay, the termination case is every time you actually see a foundational standard reference. And so we first tried to solve this problem by not even thinking about infinite recursion other than cycle detection, but instead by saying, how can we drive that to actual recursion, to keep on searching as long as there's new information being found. Now, the actual hypotheses as to how we do recursion limitation now, the only thing we've implemented is cycle checking. So I don't have a great answer for you for the rest of that. Some hypotheses I might have are mostly related to the earlier piece I showed about how we build up a custom checklist. So the idea of what we're trying to do there is we're trying to capture both implicit and explicit guidance by a given user of what the system should be doing. So if, for example, if you use Cursor for programming, you may be familiar with Cursor rules, which are kind of the perpetual structure that the system uses for every generation it produces. And our vision there is to kind of create the requirements development equivalent of Cursor rules. So you can write up an instruction set and have that be part of the guide every time you're doing this. And we suspect that sometimes those will implicitly end up including some termination cases. So some statements that, hey, as long as the output you're seeing follows this pattern, for example, as long as the final statement includes concrete thresholds or tolerances or something else, depending on exactly the artifact you're creating, whether it be a requirement or a test plan or something else, then accept that. So it could come from an override, it could come from a standard, it could come from an external resource, but you don't need to keep on following that recursion if you see that. So that's the closest we've got. A very long-winded answer.
And your auditors, do they expect that you follow that through all of those chains and they've called you on things like that?
Very, very good question. So this is one of the cases where, yes, many auditors will expect you to follow the chain for as long as there are open questions. So for example, something really concrete that came up this morning with one of the projects we worked on. So we do a lot of work on new mobile manipulators. So think robots that have some arm on a mobile base that walk around, wheel around a warehouse and pick things up and drop them off. So one of the big problems with systems like these is that many of them will use some sort of input to their safety system that is also used for navigation. For example, they'll want to use LiDAR input for both navigation and for safety. So the result is that, for example, you have some sort of repeater or relay that processes the LiDAR or encoder input if you're using encoders, even if they're certified. And so one of the big things that happens is that if you end up doing something like that, when you go to TÜV-SÜD for a certification, one of the things that gets demanded is that you get asked, hey, did you actually validate that you're properly using that communication channel all the way from the sensor to your final controller, or not even the controller, all the way to the contactor for the safety function as a black channel? So are you properly validating continuously that the channel is live, otherwise shutting down the safety system? And that's exactly one of these cases where we need to keep on digging and keep on traversing down that set of references. But as you can imagine, it's not always the case. That's just one thing.
Oh, thank you. Thank you.
Ikue asked, I saw some checkboxes for standards. Can you please provide a complete list of standards that the system can currently cover? Yes. Okay. So to answer the question about user-provided standards versus internally developed ones, you can see on this page everything that we've already ingested. So these are standards that we've purchased licenses to or negotiated licenses that allow us to resell or otherwise surface as a consultant to our clients. Those include things like some from automotive, some from aviation, some from the electrical world, some UL standards, et cetera, et cetera. But one of the biggest things we built is an automated mechanism to ingest new standards. So we kind of take a dual approach to this. As you can imagine, there are copyright constraints with a lot of these standards, and the default licenses don't allow us to surface them to you without you indicating you also have a license. So we actually do that for some of our standards. So, for example, for any SAE standards that we have parsed our own licenses of, we actually require the user to prove that you already have your own license, just so that we don't violate any of the copyrights. For others, the way we currently do this is we don't surface it to the user. We just have an automated process on our side. So as soon as a customer comes in and provides a new standard, whether that be something open or something that's proprietary, for example, an internal standard at a big company, we are able to parse that out and present it as a framework in the same view that you were seeing a minute ago. So yeah, this is the full list, and we can share that after the fact. But it grows every day. So basically, every day we're finding new standards that we want to import, bringing those in, purchasing licenses, partnering with clients to bring in their copies, all of that. I hope that answers your question. Cool. Victor asks, how does it read standards? Are the relevant standards processed and preloaded into software by you? Can take standards or users and use them? IC 62304. We will get that written down and make sure that we pick that up in the future. One point that I'll also make, it took us a long time to learn this, but standards parsing is a really good problem to work on because there's a lot of really dense multimodal information in standards, but it shows up in consistent ways. So whether or not you want to use this directly in the platform, one thing that we should definitely talk about, we have these really specific parsers that can carve out graphics, that can carve out tables, can interpret nested tables, and do some other stuff like that to be able to extract really specific information from standards. And by building programmatic ways to do that, we're able to consider much more complex information. So definitely something we should talk about. And then last question I see here. So can it account for order of precedence when there are sections of applicable documents that are superseded by others, such as contract specifications? Yes, that's exactly what we worked on with the DO-160 example I was stating earlier, where the idea was that, for example, the internal standards will overwrite, for example, frequency ranges stated by DO-160's RF tests, and then specific test specifications will also overwrite those further. And so we let a user basically layer these on sequentially. I can show you a really cool interface we built for doing this, where especially when you're writing QTPs or other test plans, you start by preparing one off of, for example, the initial requirement says start from DO-160G, and then you can select the next requirement that says, okay, now replace this with some items from my internal standard. And you can say, overwrite this or edit that based on this additional requirement. And basically apply a series of requirements based on your order of precedence. And you can back out, you can say, hey, reapply this one on top of this. There's some really cool stuff you can do. We're building a nice diff interface for that now. So we'll be really excited to get some feedback on that once it's actually up and running. Okay, 1 minute before the end. I'm sorry to have talked straight for an hour and a half. Hope this was interesting to some of you. Right. The most important piece that I think I have not yet stated that will be present after the fact is right at the end of my deck is my contact information. Please feel free to shoot me an email, call, a text, or find us on our website, Saphira.ai. Always excited to talk more about this with more great systems engineers, requirements engineers, compliance engineers, all of the above. Thanks, guys.
You mentioned this morning that on YouTube you had a series of videos also. Can you put in the chat or something, maybe a link to those?
So the YouTube videos are kind of funny. They are split between my channel and Saphira's channel. And if you spend too much time on my channel, you'll find videos of me from 15 years ago playing the guitar. But other than that, there's some great demos of Saphira as well. So let me share both of those links.
While you're posting that, we certainly thank you for your time. It was very good presentations and appreciate the multiple sessions. A lot of good questions and answers.
Kevin, Lou, thank you so much for the opportunity to present. Thank you all for attending. Really excited to continue the conversation with Eddie and all of you.
Thank you, Akshay. That was very good, very insightful.